Hello everyone and welcome to Python 2. In this class we'll be covering chapters 7, 8, 9, 10, and 13. To begin, we're going to go ahead and get started with chapter 7. So in the previous Python class we covered things like if statements, loops, file management, try except statements, and etc. from there. However, that is all foundational. You will need all of that information in this class as well. So with that being said, let's go ahead and get started. So in this specific chapter, we're going to be covering what sequences are, an introduction to lists, list slicing, finding items in lists, useful list methods, copying lists, processing them, having two-dimensional and three-dimensional lists, followed by a special type of list or sequence called a tuple, and then lastly, plotting list data using matplotlib. So we've seen sequences before. Sequences are objects that contain multiple data items. An example of this would be the range function that we've used in the past. That range function returns something called an iterable. So here you can see we have range 5, which returns an iterable 0, 1, 2, 3, 4. That's an object right there, and we're going to be talking about object-oriented design in this semester. So an iterable is not a list. It's a different type of object that contains an iterable sequence of numbers. Similarly, and we'll talk about this in the next chapter more, we also have strings, which strings are not just a native data type. They're not like a base data type like an int or a float. Instead, they are a collection or a sequence of characters. So here you see s equals hello world. And in this case, we have, realistically here, it's a sequence of HELLO space and then the rest of the world. So you can see that we have sequences and we've been using them this entire time. So in Python, there are two different types of sequences. There are lists and tuples. Specifically, when I mean two different types, I mean either sequences are mutable or immutable in Python. So mutable meaning that they can be changed, and immutable meaning they cannot be changed during their runtime. So imagine that mutable is you're working with clay, you can mold it, you can change it, just like any other data type. Immutable data types like tuples, however, are cast in stone. You set the concrete, you're done. The only way you can change it from that point forward is if you actually go back and destroy it or delete it, whatever you want to do with it, and recreate a brand new one. You can't really add onto it or change it. So lists in Python look as such. So the way that they're going to be done is you're going to use the variable name that you have, so my list equals, and then you're going to use brackets. So you're going to use a beginning bracket and end bracket with each of your data items separated by commas. Now these data items here can be any different types. So they can be ints, floats, strings, whatever you want them to be, and you can mix them as well in Python. Now I preface that with, in other languages, sometimes you cannot mix them. Sometimes in certain languages, they have to all be the same data type. But in Python, we can mix them. So we can have a list with ints and floats and strings and so on. Now, once we have our list, we have all of our data items in it. If we want to see what's in our list, we can use the print function here, which these three arrows here meaning output the actual structure of that list. So we have item 1, item 2, item 3. So we can use the print function just like before. Now, if we have something like an iterable or other type of object, we can actually use the list function here to convert that to a list. So as I said in the previous slide, the range function returns an iterable. That is not the same thing as a list. In this case, though, we can use the list function, just like how we would cast an int or a float. In this case, we're using the list function to change the range function iterable into a list that we can work with. Here in this case, it's going to bring back a list of 0, 1, 2, 3, 4. So here's an example of the different list types we have in Python. We have a standard list, which is numbers equals 1, 3, 5, 9. That's just how we do a standard numbers list. If we want to have a list of strings, we do names equals, and this can, again, these variables can be anything. Names equals Ben, Meg, and Jim, Jean. Again, notice the brackets, notice the commas. If we want to mix data types, we can do that as well. And here we have info with a string, a number, a string, and a string. This could also be a number if you want, but for phone numbers, you usually put them as strings because you're never going to be adding or subtracting them. Going from there, we have our list for range intervals. So if you ever wanted to make just even numbers, like if you ever want a shortcut, you can take the range function, start it at 0, or wherever you want to start at, end it, not including 10, and increment by 2. So this will give you 0, 2, 4, 6, 8, as you see right here. So this is how you can do these different types of lists. And again, right here, you can print the list just like that. Moving on, we now have what's called the repetition operator. So in a lot of cases, we have long lists of numbers that we don't want to have to write out. So for instance, imagine you wanted to create a placeholder list of 50 zeros. Do you really want to go back and write the zeros with a whole bunch of zeros like 0, 0, 0, 0, all 50? Or would you rather take a single zero and multiply it by n being the number of zeros you want? So you can do bracket 0 bracket times 50, and what that would do is that would actually give you 50 zeros. After you have these long lists, we also want to be able to iterate over them. And just like before, we can use the for loop, as you see right here, to actually iterate over them. So we can say for item in list, and then we can actually access each of those items so we can print them. Now, I preface this with, you are getting the item here. Okay, you're not getting the actual, like we'll talk about indexing in a little bit, but you're not getting index, you're getting just the item back. So here's an example. So if we have our numbers, so we make a bracket 0 bracket list, so it's just a single 0, and we make a whole bunch of numbers. So we're making times 5. So this is going to take this 0 we have here and multiply it by 5 and store it in this new variable called more numbers. When we iterate over that, we can print the items. In that case, it'll print 0, 0, 0, 0, 0, 5 zeros. Okay? Now, when we have a large number of items, we want to be able to determine which item we're looking at. So we can iterate over the items, but we want to know which place an item is at. So we have what's called indexing. So indexing enables us to actually look at and specify the position of a list element. So an example real quick, we come over here and we say my list equals, and let's just give it 0, 1, 3, 5, let's say 7, 9. So just a whole bunch of odd numbers. I'll take out 0 just to keep it simple. And if I say print my list, it'll print, if I run that, it'll print 1, 3, 5, 7, 9. But if I just want the third element, I can do 3. Okay, that's going to print 7. So notice here, when I said 3, it did not print 5, it printed 7, because all indexing starts at 0. So the index of 1 is 0. So if I print my index list, print my list of 0, it'll give me 1. If I print my list of 1, it'll give me 3 because it's 0, 1, 2, 3, 4. So the last index in this list is 4. It's going to be the length of the list. We have 5 numbers, that's the length, minus 1. So if I run that, you'll see we get 9 now. So that's how we can use indexing there. We can also use negative indexing, which will come in handy later when we look at list slicing. So when we're doing the negative indexing here, we can actually take this and we can do something like minus 2. We run that, it'll give us 7. The way that works is we start at 0, we go wrap around the back at the end of the list, we go minus 1 for 9, minus 2 for 7. So imagine that you have a continuous circle here, and if you go forward, 0, 1, 2, you go forward, that's one way. If you go negative, you go on the opposite end, you start from the end and go backwards. So we have our negative indexing, we have our regular indexing. That's how we can access different elements in this list. So just to make sure, because if we go over here and we change this to, let's say, 9, we're going to get what's called an index error right here. Because there is no 9th, or I guess in this case 10th element, because we start at 0, there's not 10 elements in the list. So we get an index error when we go out of bounds. So to check that, what we can do is we can come over here and say index equals 9, and we can say if index is less than len, so the length function of my list, like that, then we can print my list of index, like that. Okay, if we do that, and if I run this now, it won't print anything because 9 is not less than the length of my list, which is 5. If I put 5, it will not run anything because 5 is not less than 5. If I put 4, it will put 9 because 9 is less than 5. All right, so with that being said, we can use the len function to help us prevent any kind of index out of bounds or index error exceptions, which we really care about. So again, like I said earlier, the last index of the last item is the length of the list minus 1. All right, so like we talked about before, lists are mutable. So let's say we now have our indexing, so now we can actually access specific items. And let's say we wanted to go and access a specific item, but then also change that item. So if we say we want the index of 4, and we say if that index, we double check just to make sure we're not going out of bounds, and then we want to change it. So we'll say my list of index is now equal to, say, 99, something like that. If I do that, I can then print that index, and at the end, I'll print the full list. So if we do that, you'll see it changes it to 99, and we have 1, 3, 5, 7, 99. Because again, the index of the fourth index here, 0, or I guess we start up here, 0, 1, 2, 3, 4. So 99 will be changed to 99 right here. This changes 9 to 99 because my list of 4, the index 4 here, is 9, but we're setting that now equal to 99. So that allows us to change certain elements in the list that we have to new values. That's what we mean by lists are mutable. However, just like before, if we change this, and let's say we do an index of, we'll get rid of this line here. Just for now, we'll go ahead and comment that out. And we'll bring these back. And let's pretend we're going to do index of 9 here. If we run that now, you'll see we get an index error. Because even though that index, we could technically add 99 as that index in this list, and some languages do that, Python doesn't do that. Python says if that does not already exist when I'm trying to change it, I'm going to throw an index out of bounds error. So you have to be careful. Just like when you're trying to print the index out, you need to be careful about changing it as well and making sure that index exists prior to you accessing it. Okay, so with that being said, let's say we have our list here. We'll call this odd nums now, like that. And we'll say we have even nums, like that. And we'll do 0, 2, 4, 6, 8, like that. What we can do now is we can concatenate these as well. So we can do that, and we can say nums equals even nums plus odd nums, like that. If we print nums now, so we do nums like that. If we print nums now and we run this, you'll see we get the even nums, so it's 0, 2, 4, 6, 8, followed by concatenating them, so we just tack the odd numbers onto the end of the even numbers. So now you see we have 1, 3, 5, 7, 9. If I were to flip these, and let's say we do even nums here, we do odd nums here, we run that, you'll see we have the odd numbers first, followed by the even numbers. Now, if we do even numbers plus even numbers, we can concatenate them to each other. And this is exactly what the multiplying by the repetition operator, the multiply by n, multiply by 2, 5, 10, 50, whatever you want to do, does. When we do even numbers times 2, so we do even nums times 2, like that, that does the exact same thing as even nums plus even nums, like that. But if we want to concatenate two different lists, we can do it just like this, with even nums, the first list, plus the second list, like that, and we now have our new list, even numbers followed by odd numbers. But again, remember, order matters here. So if we flip these around, the order of the list will flip around as well. So be careful about that. If you want, you can do the same thing with the augmented operator. So just like we did when we do the plus equals instead of equal, or just the plus sign, you can use that as well. All right, so here's that same example again. If you guys want to see this, it's going to be in the slides as well. We have our even numbers here. We have our odd numbers there. We can concatenate them. And this is one way another way we can iterate over a list with a while loop here. So you'll see we have index equals 0. We'll say while index is less than length of nums. We get that index and we multiply it by 10. We add 1. So this is going over the entire list that we concatenated and multiplying everything by 10. So if we were to do that over here, just for you guys to see, we'll do index equals 0 while index is less than len of nums. We'll then do nums of index equals nums of index times 10. Then we'll print nums at the end. So if we do this, you'll see, give it a second. Oop, I forgot the actual increment the index here, so we'll do index plus equals 1. Run that now. And now you see we have 0, 20, 40, 60, 80, 10, 30, 50, 70, 90. So by doing this, we've concatenated the two lists up here, and iterating over the list with this while loop here, we're able to access each index, just like that, and multiply them by 10. Okay, so it's a little bit of a checkpoint here. If we ask the question, what will the following code display? We have nums 1, 2, 3, 4, 5. If we say nums of 2, we go 0, 1, 2, and we're setting this to 99. So we'll get 1, 2, 99, 4, and 5. If we ask what will the following code display here, we say for n in list of range 1, 5, 2. If we print n now, we'll see that we're going to print range here goes 1, starts at 1, increments by 2, so we have 3. Increments by 2 again, we get up to 5, but again, we do not include the last number here. So it's going to be 1, 3. So we're printing 1, 3. Now, the caveat here is you do not need to use list range. Okay, if you're doing a for n in list range, you do not need list. List is not doing you any favor here. I put this here so that you guys do not think you always need to use the list function when you use the range function. If you are using the range function here with a for loop, you can take this list part out. You do not need that. The only time you ever need to cast a range function like this, the range iterable, with the list is if you're storing it in a variable and you want it saved as a list that you can work on later. Now, if we ask the question, what will the following code display? We have 1, 2, 3, 4, 5, and we're going -2. So we start at 0, -1, -2. So we'll be printing 4. And the way we find the number of elements on a list is we use the length function of that list. All right, so let's go ahead and try this. Let's design a program that asks the user to enter a store's sales for each day of the week. The amount should be stored in a list, and we should use a loop to calculate the total sales for the week and display the results. So we'll go over to our actual 7.1 right here, and we'll go ahead and get it started. So we'll do def main, just like this. Just go ahead and set up our Python file, and then we'll do if 2 underscores name 2 underscores equals quote 2 underscores main 2 underscores colon. Then we'll do main here like that. And by doing this, now we have our Python file set up correctly. All right, so once we have it at this point, we can go ahead and design a program that asks the user to enter the store sales for each day of the week. So it should be stored in a list. So if we have 7 days in a week, so we do days in week is equal to 7, so we have 7 days in a week. We can then do sales per day is equal to, and we'll do 0.0, so floating point value, times the days in week. This will create a list. If I print this out, it'll create a list that is 7 zeros. So imagine that each week the sales per day resets. That's what we want. All right, so once we have this, we now have our list created, and now we need to go through and actually ask the user to enter the store's sales for each day of the week. So what we'll do is we'll say while we need an index, so we'll say index equals 0, and we'll say while index is less than the len of sales per day, we'll say sales per day of that index is equal to a float input, because we want to store it as a float, of enter the sales for day. And what we're going to do is we're going to make this look a little nicer, and we'll put a day number. So we'll do dot format like that, and we'll do index, which is the current day we're looking at, plus 1, so the days start at 1. All right, so what this is going to do is if we run this now, it'll say enter the sales for day 1. Put a little space, colon and space here, just to make it look a little nicer. So we'll say enter the sales for day 1. So let's say $100 there, 120, 123, 13, 54, say 32, and then let's say 25. Now, if you notice, again, what's the problem here? we are not incrementing the index. So we need to do index plus equals 1 to actually get this while loop to work. Make sure you're not falling for that same pitfall there. Okay, so if we run this again, we'll do 100 again. Now it works. We'll do 23, 12, 13, 15, 65, and 43. Okay, it works. We've gone through, and every single one we've gone through and we've added the stuff, the actual sales for each of the day. If we print that now, we can go ahead and print sales per day, and we'll see it work. I'll just put in 5s for everything to make it a little bit quicker. So you'll see we have 5, 5. I added a 55 here, 5, 5, 5, 5. So that works. However, like we learned in the last class, we do need to worry about input validation. So if I put in the word 10, that's going to crash the program because we're trying to cast the word from input, which brings in a string. We bring it, pass it to the string 10. Well, you cannot cast the string 10 to a float. So what we need to use is an input validation loop. So we'll do input validation loop like that. And we'll say while true, because we're going to keep going until they get it right. We're going to then do try. I'll go ahead and tab this in, tab it in again, and we're going to try to do that. We'll then do accept like that. And if it breaks, we'll do print invalid sales for day, something like that. Now, the problem with this is this will continue to run repeatedly because we have a while true loop. So when this works, we need to stop this while loop. So we talked about this previously before, and what we'll use is after this is done, we'll say if correct sales entered, break out of loop. So we'll put a break statement right here, just like that. So we'll enter sales, and then if it's corrected, we'll break out of the loop. If it's incorrect, we'll print invalid. So what this is going to do is that by using this break statement here, the break statement is going to prematurely, or I guess in a way, you can almost think of it as like a force quit. It's force quitting this loop. Once we get to this point, it's going to go to the nearest loop, which is this one, not this one. It's going to be the closest one, which is this one, and it's going to stop it. So this is the simplest kind of input validation we can do because it will continue to go until this line right here, line 13, has no errors. Okay, so once we do this now, if I put in the number 10 now, it's going to say invalid sales. So I'll go ahead and put all the 5s in again because that works now. And now we're off to the races. Okay, so now that we have those actual sales, we need to iterate over those sales and then calculate, like it says right here, the total sales for the week. So we're going to do is we're going to do for day in sales per day. I'm going to iterate over that. And we're going to say total sales up here, total sales equals 0. And we'll say total sales plus equals day. Then we can print total sales for week, just like that. And then we'll go ahead and do dot format, and we'll put total sales here. All right, if we run that now, put a whole bunch of 5s in again, just like we did before. There we go. So now we have a few 55s and the rest are 5s, and that equals out to 185. Now, if we wanted to go ahead and actually format this better, we can put a $ here because it is money. And we can do a colon inside the curly braces, dot to F. This part right here is going to tell us that we need 2 decimal places, exactly. This tells us that we're formatting, and this is just a $ that makes it look nicer. So if we put this in again, let's say we have a whole bunch of 5s, and now let's say for some reason we have a repeating decimal, so we do 34.3s. And this 3 just keeps on repeating a whole bunch of times out. So we don't really want that, but we don't have to worry about it because that colon.2f truncates it to 2 decimal places, and now we have our $. All right, so that is how we went about actually putting together this piece of code that I'll actually ask for the store sales and store it in a list and calculate the sales for the week. So what I want you guys to do is I want you guys to pause the video and try this problem yourself. So what I want you to do is I want you to design a program that lets the user enter the total rainfall for each of the 12 months into a list, and that program should calculate and display the total rainfall for the year, the average monthly rainfall, and the months with the highest and lowest amount. So go ahead and give that a shot, and then unpause the video when you're ready to see the answer. All right, so did you give that a shot? All right, so let's look at this together. So what we're going to do is we'll open up 7.3 here, and we're going to do the same thing. So we're going to do def main, and then we're going to come down here, and we're going to say if underscore underscore name, two underscores, equals, quote, underscore underscore main, colon, and we'll do main just like that. So we have our Python file set up again. And just like before, we're going to do the exact same thing. So we need 12 months in a list. So just like we did over here, where we had days in week is 7 and sales per day 0 times days a week, we're going to do months equals 12. And we'll say rainfall per month is going to be equal to a placeholder for 0.0 because rainfall can be a decimal times 12. Okay, so we have 12 months of rainfall right there. If we print that out now, you'll see that we again have a whole bunch of zeros, 12 zeros here. All right, so just like before, we're going to do the exact same thing. We're going to do index equals 0. We'll say while index is less than rainfall per month. Remember, we had to put the len of the rainfall per month, just like that. We're going to then say while true, our input validation loop here, we're going to try, and we're going to do monthly, or we'll actually do rainfall per month of index is equal to float of input, enter the rainfall for month, and then we'll put the month there, and we'll use the dot formatting to put the month there. So we'll do index here plus 1. All right, so now we have our enter the rainfall for month is 1, 2, 3, 4, 5, 6, all the way down. If we do accept, we then want to go ahead and print invalid rainfall amount, and then we'll go ahead and break here, just like that. All right, so now we have everything we need here. So with this being said, we can go ahead down here and we can print the actual rainfall per month. And one last thing we need is we need to do index plus equals 1, just like before. All right, so if we run this now, let's say we put in 3 inches of rain across the board, everything's the same. So now we see we have 3s across the board in our 12 months. All right, so this is how we're actually going to get the user input, exactly the same before. If I show you both these, you'll see this lines 4 and 5 are the same as 4 and 5 here. Actually, this 12 should be months here, just like that. So we actually use that. We don't have any magic numbers that way. So now we have our months, we have our rainfall, we have index equals 0, and we say while index is less than length of rainfall per month, while true, we break this up. All right, so now we have our numbers. What we need to do now is we need to get the total, the average, and the months with the highest and lowest. So before we use a for loop because we didn't care about which index we were looking at, but because we do need the months with the highest and lowest, we're going to say total rainfall equals 0. We'll say month, or let's say highest rainfall, and we'll set that to rainfall per month of 0. So we just have a placeholder. We have lowest rainfall. We'll set that to rainfall per month of 0. Then we'll say while we'll reset index to 0 too while we're here. So we'll do index equals 0 again. While index is less than len of rainfall per month, just like before, we're going to say total rainfall plus equals rainfall per month of index. Then we're going to say if rainfall per month of index is greater than the highest rainfall, then we're going to say we'll have the highest rainfall equals rainfall per month of index. Now, we also have to keep track of the index of this. So we have the actual rainfall amount, but we'll have to also have highest rainfall index. We'll set that to 0 because, again, this is the same one here. So if I do this, just like that, and then we'll have the lowest rainfall index equals 0. and we'll set that to the same 0 here. So we're using 0 because we're just going to use a single element of the list. We just choose 0, and everything else will sort itself out, because if 1 is greater than 0, it'll change it to the highest one. We're just giving it a placeholder value of the first element of the list. So if it is greater, we'll set that, and we'll say highest rainfall index is equal to index. Same thing here, we'll say if rainfall per month of index, let's go ahead and space this out a little bit so it's a little bit easier to read. If highest rainfall per month of index is less than the lowest rainfall, like that, then we want to do the same thing. We want to do lowest rainfall equals lowest rainfall, or we should equal rainfall per month of index, and then we'll say lowest rainfall index equals index. All right, so let me break this down. So what this is doing is we're saying while the index that we have, or we're currently on, is less than this, we're going through everyone. So we're going through month 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We're going to add the rainfall up of each month. So this is just adding up. So we'll say add up rainfall for each month. So we're adding up a total. Then we're going to check and say, see if the current month's rainfall is less than the current record. So when I say record, I mean, let's assume that like we're starting the record over, like let's say like a Guinness Book World Record kind of thing. And let's say for each year we reset it, and each year we have to reset it to something. So up here when we do 0, and we have these 2 lines right here for highest, and then we have the same 2 lines for lowest, what we're actually doing is we're saying, hey, look, we have 0, and we have the rainfall for that month, which is also going to be whatever the value is. So what I'm trying to say is, if we don't have anything to compare it against, the first month is going to have both the highest and the lowest, because we have nothing else to compare it against. Now let's say the next month after that has higher rainfall. Well, then the new highest rainfall will be reset to that rainfall. So you can see that here. We'll say if that next month's rainfall is greater than the current maximum we have, then we're going to reset the maximum, the record, to the newest highest value, and we'll keep track of which month had that rainfall. We'll do the same thing for the lowest. All right. So then we need to have our index plus equals 1 to iterate through the months. And at the end, we can print total rainfall. We'll do dot format. We'll do total rainfall. If we print average rainfall, what we'll do is we'll do dot format, and we'll do total rainfall again. We'll divide that by 12 to get an average. Actually, we'll divide that by months here to make sure we're using the variable above. Then we'll print lowest rainfall month. We'll do dot format. Now again, when we do the actual month, we want the index. We'll do lowest rainfall index. And then we'll print highest rainfall month. Same thing here. We'll do dot format. We'll do highest rainfall index. Okay, all right, so now that we have this actually done, let's go ahead and give this a shot. So if we run this, and let's say we have a rainfall of, let's say, 15 for the first month. Now, if we have 20 for the second month here, you'll see that now the new highest rainfall here is going to be set to 20, because it says, is 20 greater than 15? This is what's going to happen later on. Not happening right now, but when we get to this point, this is what's going to happen. So 20 will be set as the highest rainfall. If I have the next month as 3, then that means that 15 now is neither the highest or the lowest. If I go through and put a whole bunch of other numbers now, so we'll just do 5, 5, 5, 4, let's say 12, 12, 12, 12, 15. All right. So it says right here that the total rainfall, which is when we add all these up, is now 120. The average rainfall is 10. So if we took all these numbers, added them up, and divided by 12, it would equal 10. Sometimes this number becomes really long, like we talked about before, and to solve this, we can put the :2f. All right. The lowest rainfall month says it's 2. Well, the lowest rainfall month was 3, right? But remember, with this number that we're looking at here, this 3, we added 1 to it so it looked nicer to display. So really, this lowest and highest should be add 1 here, and we should add 1 here as well. So if we run that again one more time, we'll do 15, 20, 2, and then we'll just put a whole bunch of 5s just because. All right, so now you can see that the lowest rainfall month is 3, which is true. Right here, it's 2. And the highest rainfall month is 2, which is correct because it's got 20 inches. Okay? So that's how we can actually solve this problem here. We now have the total, the average, and the highest and lowest amounts. All right, so now that we've seen how to actually manipulate lists and create lists, we can now move on to further manipulations. So list slicing is when we can actually take a list and cut basically a chunk of it out. So it's a span of items that we can take. So we can give it a start index, an end index, and a step. So if we don't choose to put a start index, it starts at 0. If we don't choose to do an end index, it gives it a list of length, or like a length of the list is used as the end index. If we don't indicate a step, it just uses a 1. All right, so the way that this looks, if we go back to the examples here, and let's say we have our, let's make a bigger list. Let's just say numbers equals 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we'll do 10. All right, so if I only want the first few numbers of the actual list, we'll say we want it to end at that specific point. So if we do print numbers, we use a bracket, and then we can use a colon. So let's say we want the third index to the 7th index, like that. So if we run this now, it's going to give us 0, 1, 2, 3. So it's going to give us the third index, 4th, 5th, 6th, and then does not include the ending one. Notice here how it says it uses the length of the list as the end index. Remember that the last item is the length of the index minus 1. So the end index does not include it when you slice the list. If we want every other one, we could do 3. And if we want to go to the end but want to have a step size, we just put extra colons like that. And then we put 2. So what's going to start at 3? Since we did not include an ending index here in this middle, it's going to use the length of the list as a spot, and it's going to have a step size of 2. So if we run that, we have 3. So we're starting on 3 still. The third index, so 0, 1, 2, 3. That's the third index. We keep 3. We step by 2, 5, step by 2, 7, step by 2, 9. All right, so now we can see that we can actually slice lists this way. We can also use the negative indicator as well. So let's say we want let's just say we want the last few elements. We can do -3 colon, like that. And if we do that, it's going to give us the last 3 because we go back. So imagine this. So we're at 0, the index. So we're starting at the -3 index. So it's 0, -1, -2, -3. It's going to give us the last 3 because we're starting at -3. And then remember, because we didn't put any number here after the colon, which is where the end specifier would be, since we didn't put an end, that end is going to be the end of the list, the length of the list. So we're at -3. We're on the -3. We do that one, and we do the last one. So we have 3. So if you want the first 3 elements of the list, we can do :3, like that. We're saying we want to start at the beginning of the list and go to the third index. So if we do that, we get 0, 1, 2. If we want the last 3, we can use -3, like we did before. And it gives us the last 3. So by manipulating and using the indexing that we talked about before with the positive numbers going from left to right and the negative numbers, which allows us to go from the end of the list back, we can use list slicing to get specific chunks of the list. So here's an example that we just sort of showed, and I'm just give a little bit more explanation here. So we have our numbers like we showed before. And if we want the first 5, we say we do not give a start index. Notice how there's no number before this colon. We're not giving a start index, so if we don't give a start index, 0 is used for the start index. So it gives us 0, basically puts a 0 here, :5. So 5 means we want to stop at the 5th index. So we have 0, 1, 2, 3, 4. That gives us the first 5 numbers because we start at 0. If we want the last 7 items, we put -7 because we're starting at 0, -1, -2, -3, -4, -5, -6, -7. So it's the 3 here, okay? And because we're starting at -3 right here, we're going to then go, because we didn't put any number for the end specifier, since we didn't put any number there, it's going to put the length of the list. In this case, it's going to be 10. So it's going to go from 3 all the way to the end, which, remember, it goes to the length of the list minus 1, because it doesn't include 10. So it goes to 3 to the index of 9 right here. All right, now if we wanted to have every other item like we saw before, we can start at the 4th item. We go to the end because we didn't put anything in that second colon, and we're going every other one. So it's 4, starts at 4 right here. Skip 5 because we're going 2 steps, so 1, 2, so we're at 6. We print 6, skip 2, 1, 2, now we have 8. All right, so that's how we can use list slicing to improve our list manipulations. All right, so another thing we can do with lists is you can actually use the in operator to determine whether an element is contained in the list. This is really useful if you're trying to check for a specific username, if you're trying to check for a specific attribute, etc. So for instance, you see right here, we can say the result, which is true or false, if we say, is this item in this list? So if I say print, let's say 10 in nums, something like that. So I say, oh, I'm going to phrase that, numbers. There you go. If I print that, it'll say true because 10 is in the numbers. However, if I do 15, it's going to be false because 15 is not in the numbers. If I do, let's say 1.1, it's going to be false because even though 1's in the numbers, 1.1 is not. So we can also do not in, just like we did before, where we use the not operator to flip the logic. We can do that, and what that'll do is it'll flip the logic of the actual in operator. So before we say true or false, true if it's in the list, false if it's not in is false if it's in the list, and true if it's not in the list. So if I come over here and say in, and I change this to not in, it now returns true. So if you ever wanted to check somebody's name for being in a list, like for instance right here, we can say, let's say we have a user list for a website. We have Ben, Megan, Jim, and Jean. We say, hey, this guy named Steven's trying to log in. Is he a user? If he is, user's found. Otherwise, it's not. So here, because of the fact that he's not in the list, it's going to be false. All right, so I know that was a little smaller section there, but let's go ahead and just sort of get a gauge on this because string slicing, list slicing is a little bit of a complex matter. So if we ask the question, what will the following code display? We have numbers 1, 2, 3, 4, and 5, and we print numbers 1, 3. Note, this is the starting position, this is the end position because of the colon. So with that being said, we go 0, 1, so we're going to start at 2, and then we go 0, 1, 2, 3. So it's going to go from 2 or from 1 here and do 2, so 1 and 2, but again, it does not include 3, so it's going to print 2 and 3. So what will the following code display here? If we do the numbers again, 1, 2, 3, 4, 5, we're starting at a negative, so we go 0, -1, -2, -3. So we're starting at 3 here, and we're going to the end because, again, we did not include an end specifier, so it uses the end of the list. So it's going to give us 3, 4, 5. So you see that right here. All right. Next, we can ask, well, what will the following code display here? If we say names equals Jim, Jill, John, and Jasmine, you say if Jasmine is not in names, we print cannot find Jasmine. Else print Jasmine's family, and we print the names. So we're checking to see, is this Jasmine's family? Well, if she's in the family, then we're assuming it's her family. So here we can see we say if Jasmine's not in family. Well, that's false because she is in the family. So she's not in names because she is in the names. So that means that we can find Jasmine. So we print Jasmine's family and we print Jim, Jill, John, and Jasmine. We print all the names. All right. So now that we've seen string splitting, we can use a file that's found on D2L called worldserieswinners.txt, and it contains a list of World Series winners. We can write a program that reads the World Series winners into a list. Following this, the program should let the user enter the name of a team and should check to see if the team has won the World Series. If the team has, the program should iterate through the winners and display the number of times the team has won the World Series. So let's go ahead and work on this. The first thing we need to do is actually get this file, worldserieswinners.txt. To do this, if you open up your D2L, your MyHGTC here, if we open up D2L, we can go, let it load up here. to the actual class here. So we'll do like 187 here, whichever section is yours. We go to content, and then we go down to course resources. If you go down, you'll actually see the Python 4e source code. If you click that, hit download, click that, go ahead and open that up for you. And here you'll see that you'll have the different chapters for each one. So in this case, we're looking for the Chapter 7 World Series winners. So what we're going to do is we're going to go back here. We're going to go to Chapter 7. And here you'll see, if we go down, we have our World Series winners. Now if we open this, let's just go ahead and open it with text edit here, just a text editor, doesn't matter what. You'll see we have all the different World Series winners. Okay, there's no years here, right? There's no years, but there's all the World Series winners. Okay, so we know that this is the World Series winners, right? And right now what we're trying to do is we're going to say, let the user check to enter the name of a team, and it should check to see if the team has won the World Series. Okay, and if they have, the program should iterate through the winners and display the number of times the team has won the World Series. All right, so what we're going to want to do first is take that file we have, the World Series winners. We're going to copy that. So copy. If you're in Windows, just copy the file. And then into PyCharm here, we're going to want to actually put that in here. So because we're going to actually need to import that file. So what we're going to do is here, we're going to paste the file in, World Series winners. So you can just right click paste. We'll put that in the actual project, PyCharm project here. So we'll hit OK. And now we have that text file next to the file we're going to do. We're going to be working on 7-10. All right, so once you have the World Series winners text file loaded in, you've downloaded it, so you have the actual file, and you went ahead and copied and pasted it into your actual project folder. What we're going to do is we're going to actually open the file. So we'll do fp equals open. We'll do World Series winners.txt, and we're going to read the file. All right, so we need to read this into a list. So the problem says right here, it says read them into a list. Well, one of the best things is we don't know how many exact lines it has. What we can do is we can say winners equals fp.readLines, just like that. And if we print this, you'll see that when you do read lines, it's going to read every line of the file, and it has all the different winners at the bottom. And it's going to be spaced on that new line character. So that's all we have to do to read the winners into a file or into a list. So we would say read winners into list. So it's just 2 lines of code to read the winners into an actual list, just like that. Okay, so after we've read them into a list, we need to ask the user, so get user input on team to check. So we'll say response, or we'll say even better, we'll say team equals input, which team should we check for? Something like that. Then we'll say for winner, or for team, or for, let's say, because we were using teams, so we'll say for T in winners, and we'll count them. So we'll say wins equals 0. We'll say if team equals T, just like that. And we'll do team dot, or T dot strip, because you notice these actual \ns down here. So we'll make sure to strip off that. Then we'll do wins plus equal 1. Then at the end here, we'll go ahead and print wins, like that, dot format with wins, just like that. All right, so let's try Boston American. So we'll copy this in, copy that, run it again. And you say it says wins 1, right? Let's check that. We have Boston American there. We can actually control F this. And just like we thought, it only has 1 win. So let's try something like the Chicago Cubs. So let's run this again. Type in Chicago Cubs. And you say it says wins 2. We have the 2 right there. So let's double check that again. Chicago Cubs. We have 2 wins, just like before. All right, so let's try something a little bit better. Let's try New York Giants. New York Giants. All right, so they've won 5 times. So what this is doing is every single time, so if I go back to printing the actual list of winners here, so if I go here and I do print winners, what this is doing is we'll do Boston Red Sox. Sox or Sox? Yeah, Sox. There we go. All right, so that's got 6. So what this is doing is it's checking what we gave it against this right here. Now notice, again, we have this \n. So we're going to have to strip it every single time because we have that \n there. So what we're doing is we're saying, is this Boston Red Sox the same as this? The same as this right here? Is this the same as that? Is that the same as that? Is that the same as that? And so on. Now what we can do is if we wanted to, we can check, we can say if wins equals 0, we can print your team never won. We can say else, we can print wins. So if I get rid of this now, and we just do that, we'll see it says, if I say a team that doesn't exist, we'll say the Penguins. It says their team's never won, because the Penguins, of course, have never won because they're not a real team. But if I say something like we said before with the Chicago Cubs, we won twice. All right, so now you can see we've read the file in. We used a function in Python called fp.readLines to make a list for us. Now, if we didn't do this, we would have to read each line in, find out how many lines there are, make a list that size, and add every line to the actual list. Otherwise, we can just use readLines, which is a simpler way to do it. And then we can say, what team do you want? Wins equals 0, and then 4t in winners, we can do this. Then we say we add the wins each time. If it's 0, they never won. Otherwise, they have won. All right. So with that being said, we've now shown that we can actually read a file into a list. Following that, we can then check that list repeatedly and iterate through it to display the number of times that teams won the World Series. All right, so at this point, I want you guys to go ahead and try this. I want you guys to write a program using the same file that reads the World Series winners into a list, and following this, it should use list splicing to display all the teams that have won in the past 10 years. Every 5th year, and the first 5 teams to have won. So go ahead and give this a shot yourself, and pause the video, and then come back when you've tried it yourself. All right, so have you tried this yourself? So let's go ahead and look at this together. So the first thing we have is we're reading it into a list, so all this other stuff up here stays the exact same. So we're going to copy this code, just copy all of it, into 7-10b. So I'll just go ahead and do that. So now what we're going to do is we don't need to see which teams won. We're just going to instead print. So we're going to print the teams that have won in the past 10 years. Now this list is in chronological order, so we'll print the teams that have won in the past 10 years. So in the past 10 years, what we're going to want to do is we're going to do past 10 equals winners. We're going to use string splicing. So past 10, so we're going to start at the past 10. So we're going to do -10 colon, just like that. So this is going to go to the very end of the list because it's in chronological from earliest to latest. And it's going to ask us, and it's going to say, give me the most recent or the latest or on the farthest part of the list, on the end of the list, the last 10. So if I run this now, it's going to give us, I actually got to print it. So print past 10. We'll run that. It'll give us the Yankees, Diamondbacks, Anaheim Angels, Marlins, so on, so on, so on, so on. Okay, so that's the past 10. That's all we had to do for that. If we want to print every 5th year, so print the teams that won every 5th year, we're going to do every 5th equals winners. Again, we're going to want to start at the beginning, end at the end, but we're going to want every 5. So again, we don't specify a beginning, so it's going to be 0. We don't specify an end, so it's going to be the end of the list. But we do specify a step size of 5. So if I run this now, and we print that out first, so print every 5th. We run that. We now have every 5th. So it starts off at Boston American at the beginning. Then this is the next 5 years, it was Pittsburgh Pirates, then the Boston Braves, the Cincinnati Reds, so on, so on, so on, and so on. All right, the last one we wanted to do was the first 5 teams to have won. So similar to this -10 here, we're going to print the first 5 teams that have won. And we're going to do first 5 equals winners. Now we could do winners 0, 1, 2, 3, 4, 5, or we could just do winners, start at the beginning, stop at 5, just like that. If we print first 5, you'll see we get Boston Braves, Giants, White Sox, Cubs, and Cubs, just like that. All right, so now we've seen that we can use string splitting, reading the list in with fp.readlines, string splitting to take the most recent 10 every fifth, and we can also take the first 5 as well. So this right here shows that you can use string splitting or string slicing, whichever one you would call it. I keep saying string, I meant to say list. List slicing to make it very easy for you to operate and work on lists.